Let's see now whether this function is differentiable. So what is differentiable? It means we can take the derivative. Well, let's see. For the first part of the function, can we take the derivative of ln of x? Well, ln of x derivative is just 1 over x. So that's an actual derivative that we take. What is the derivative of ln of 2 minus x when x is less than or equal to 1? Well, if we differentiate it, we would have 1 over 2 minus x times the derivative of 2 minus x, because we're using the chain rule here, and that's just minus 1 over 2 minus x, and that's another actual derivative that we take. Now the question is, what happens at this critical point, at this, ambiguous point, so to speak? Can we have a derivative there or not? And we use there the Newton rule. So we want to know if the limit as we approach 1 from the left side and from the right side are equal. So let's use that Newton rule. Let's remind ourselves. First, let's do it from the left side. What is the limit as h approaches 0 from the negative side of f of 1 plus h minus f of 1 divided by h? And let's remind ourselves, what are we actually doing here? Well, instead of having 1 for x, we're incrementing our value by h. And we want to know how the function changes when that increment is really small. So as it approaches 0, but it approaches 0 from the left side, from the negative side. So what does that mean? Well, look, the function of 1, when is the function of 1? That's when x equals to 1. That's ln of 2 minus x. So we're gonna substitute here ln of 2 minus x plus h, because this is the new input. It's not just x, it's x plus h. So it's not just x equals to 1, but x equals to 1 plus h. Let's do it. We would have the limit as h approaches 0 from the negative side. H approaches 0 from the negative side. And here we have ln of 2 minus, and instead of x we said we have 1 plus h, and let's keep 1 plus h in brackets so we don't miss anything. Minus, what is the function of n? When x equals to 1, the function takes the shape of ln of 2 minus x. So in our case will be ln of 2 minus 1, because we're checking at the point x equals to 1, divided by h. So h approaches 0, we will have 0. Now let's do some substitutions here. Ln of 2 minus 1 plus 0, because we substitute 0 into h. 1 plus 0 is 1, 2 minus 1 is 1, so over here we have just 1. Ln of 1 minus 2 minus 1 is again 1, so minus another ln of 1, divided by 0. What is ln of 1 minus ln of 1? That's just 0 minus 0, so that's 0 over 0. And remember that 0 over 0 is not defined, which means we have to use our L'Hopital to try it and solve. Well, let's solve our thing with L'Hopital. H approaches 0 from the negative side, and we have this whole thing divided by h, and now we take the derivatives of the upper side and the lower side. So if we differentiate this and we differentiate that, the variable of interest is h. We're dealing with h now. So what would that look like? F of 1 plus h derivative, that's going to be ln of 2 minus 1 plus h derivative, minus f of 1 derivative, that's just ln of 1 derivative. ln of 1 is a value, is 0, while the derivative of any constant is just 0. So minus 0 divided by h derivative. Well, h is the variable of interest, just like it used to be x before. The derivative of x was 1, so in our case the derivative of h is 1. What is ln of this whole thing derivative? Well, what we're going to use now is the logarithmic rule for derivatives. ln of 2 minus 1 minus h. So that's going to be, the derivative of it is 1 over 2 minus 1 is just 1, and then minus affects the plus h into minus h. So that's 1 minus h times, what is the chain itself? Well, the chain itself is 1 minus h derivative, because this is not just h in the brackets, it's not just the variable, is 1 minus h. So we differentiate the bracket itself, divided by 1. So we have now 1 times, what is 1 minus h derivative with respect to h? Well, 1 derivative is 0, minus h derivative is minus 1. So we have minus 1 divided by 1 minus h over 1. So as a result we have minus 1 over 1 minus h, and as the limit is that h approaches 0. So if we substitute 0 into h, we would have minus 1 over 1, and the result is minus 1. That's the value of this limit. In the next video, let's solve the limit from the other side.